One challenge that typically comes up in new or existing projects is the retrofit of old machines. Older machines in an industrial setting, they have a varied lifetime, but the typical industrial machine component is meant to last between 10 to 20 years. And if you think about what has changed in the last 10 or 20 years, it's quite a bit. So when it's time to upgrade an older machine, you have to deal with, hey, what is the actual state of the lifetime of these components in the machine? Things hit their end of life, there are no longer spare parts available. It becomes very difficult to source components at that point. And these are things that often push customers to a upgrade in the first place. Other things are like extended functionality. But some of the other challenges that you'll find is that the safety standards in the last 20 years, they've changed completely. So the whole machine concept may have to be revisited as far as safety is concerned. When we receive a machine or we look at retrofitting a machine, the most important thing that we're looking for at first is what documentation is available. Because if you think about it, just like buying a used automobile, you may find cases where you have no documentation of maintenance, of prints, of any kind of thing that has gone on with the machine, changes, even the PLC code may not be available. And these things greatly impact the scope and the timeline of the project, especially when you're dealing with a retrofit. From a controls perspective, one of the things that can be quite challenging is that even though we can physically watch the machine, we understand how it's working, most of that knowledge about the machine is through observation. It's not the actual nuts and bolts of the way the machine was programmed. So when you talk about a retrofit and you want to expand a machine's capability, add data collection, add this or that to it, the first hurdle is the hardware. So the hardware may be completely out of date. You may have a PLC that, the software is available, but you might have to run Windows XP to be able to access it, or the hardware is in. Hold on, I think re-catch my thought. Good thing you're editing all of this together. So when you want to expand the code beyond what was originally planned, you run into these problems where what we think the machine is doing may not actually be what it's doing. So the first hurdle is making sure that the hardware is capable of doing what we want. If it is, then we can go through, try to understand the code. Eventually, we do understand the code, and then we have to see how much of a change really is it. In the field retrofit, something that may seem very simple could be far more complex than it actually seems, because the original intent of the machine was not to do this. And it seems like a simple add, but actually it changes a lot of other sub-functionality of the machine. Once we've sort of completed this kind of analysis, so for in the field retrofits, when we have a machine that is actually at the customer site, and the customer needs us to add functionality or change out something about the system, the preferred way to do it is always, hey, if you can stomach the downtime, if you can do without the machine, if you send it to us, then we can thoroughly go through the machine and make the changes, the upgrades as needed, and thoroughly test it. But the reality is that often this downtime can't be tolerated, so these projects have to be done in the field. And so one of the strategies we take is sort of making sub-functionality what we're changing and making sure that we have the ability to test it all here before we get on site. Then once we're on site, we're in crunch time with the customer. The downtime is very limited, and we have to execute the plan and hopefully have no surprises. This can be quite challenging because one of the things about retrofitting older equipment is that you have to expect some surprises.